Alright, so remember there are two top types of polynomial division. What are they? Long division.
Short.
It's not short.
Regular.
Synthetic division. So remember that yes, long division takes a little bit longer, but remember that synthetic division only works in specific instances. So there will be some times where we have to use long division. So that means that we need to make sure we know how to do it. So we don't need to write this down. Basically, it's just kind of talking about a big thing here is that the degree of what you're dividing by has to be less than or equal to what you're dividing into. Okay. And then it tells us, reminds us, hopefully, about what our different parts are. So remember that if I have something that I'm dividing into, right? So that would be f of x. The other way that we could write that would be divided by our divisor, which is d of x, and that equals q of x plus r of x. Basically, they just multiplied everything by d of x. So, let's also remind ourselves that if I have long division, where does our dividend go?
Inside.
The inside.
This is so silly and goofy.
Where does the divisor go? On the outside. What is our quotient? It's not a product. Product would be multiplication. But it's going to be the answer or the solution on top. So it will be the quotient. And then what's our remainder?
It's like whatever's left over.
It's the stuff that's left over. So usually we'll kind of write it off to the side.
This long division stuff.
Mm-hmm.
Didn't we learn this in like 5th grade?
With normal numbers, yes.
Normal numbers.
And we're going to look at an example of that right now.
Because I don't even remember that.
So if I had something like 53 divided by 4, and I wanted to complete that by doing long division, what goes where?
4 on the outside.
The 53 goes on the inside, and the 4 goes on the outside. And then what do we do?
7 times 4 goes in.
Not 53. It's 5.
Oh.
Remember, you start with your first number first. So how many times does 4 go into 5? 1. And then what do we do?
Put a 4.
Multiply. So 1 times 4 gives us 4. And then what do we do? Subtract. And we get, and we have to bring down our 3. And then we say how many times does 4 go into? 13. So then we get 12. And again we subtract and we get 1. So we have a remainder of 1. But how would we write that as an answer for our fraction?
13.25.
No. I mean, yes, that's correct, but we want to leave it as a fraction, not as a decimal. 13 and 1/4. So yes, our and basically is the addition. We just don't have to write the addition here. So what form is my first one in?
Improper fraction.
It's an improper fraction. And then what's our second one in? The mixed number. So basically, when we look at our polynomials division, we're going to be given stuff that's kind of written like a fraction with one polynomial over the other polynomial. So we can think of that as an improper fraction. And we then want to perform our long division so we can write it as a mixed number. Yes? Alright, so let's look at an example. before we do that, we do need to remind ourselves, when are we allowed to use long division? I mean, it is, but I'm not going to give you
Long division. Can we use
Synthetic division.
when can synthetic division not be used?
long division?
Something doesn't
I mean, technically, even if it did factor, you could still use the division.
when the degree of d of x is greater than
So yes, your degree of the bottom has to be equal to or less than the degree of the top. But in general, remember synthetic division, whatever you're dividing by, it has to have a degree of 1. So there's really specific cases that we're allowed to use synthetic division for. However, with long division, it can be used for any problem. Which is why
Thank you so much.
we need to be able to know how to do it, because sometimes we're not going to be able to use synthetic division. So even though we like synthetic division more, synthetic division is a little bit quicker, there are some instances where we will have to use long division. So we have to know how to do it.
When did you learn synthetic division?
Last year, no, we too.
Okay, I thought we learned it recently.
We're going to learn it on Monday.
Okay.
Alright, so when I'm doing division, what order do we have to make sure our stuff is in? What order? So if we had 2x plus x squared plus 1, are we good with that?
we have to do like in order from like the exponents.
Your exponents, we want to order our exponents from what to what?
Greatest to least.
Greatest to smallest. What's the other word for greatest to smallest?
Greater than.
No, like order. Like if I said, put this in blank order.
Chronicle.
Descending order.
I didn't finish it. I didn't say it.
So it's descending order by exponent. Your divisor and your dividend can also any missing terms. If they do, we need to use a placeholder of 0. So like an example of that would be, if I had x to the 4th plus 2x minus 1, am I missing terms? Yeah, what are we missing? An x to the 3rd and an x squared. So I would need to put 2 placeholders of zeros to make up for those missing things. And that's for your divisor and your dividend. Yes? So that's all the setup. That's all we're worried about so far.
Okay, so the missing terms would be the x cubed and x squared. Okay, awesome.
So, as an example.
At least I understand that.
So it says divide negative 5x squared minus 2 plus 3x plus 2x to the 4th plus 4x cubed by 2x minus 3 plus x squared.
Yeah.
Well, You can become a textbook writer and make nicer problems.
I would like to become a textbook writer. That eliminates all other textbook writers.
Alright, so if we wanted to do this division problem, okay, one, we said we're always allowed to use long division, which in this case we would have to use long division because what we're dividing by has a degree of 2, so we would not be able to use synthetic division, okay? But then what do we have to worry about?
Placeholders and order.
In order. So it's not going to be very easy to tell if we need placeholders until we put it in order. So let's do that first. So what would the correct order of our dividend be?
Which one?
Dividend is the first one.
2x
2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2. So are we missing any terms for that one? No, that's nice. And then what is our divisor? Are we missing any for that one? Nope. So now we can start our division. What goes on the inside? The top. Now, similar to our division when we had just numbers, okay, I want to start by looking at just the first term, which would be 2x to the 4th. And it's really we only have to worry about the x squared. So basically, we're dividing x squared into 2x to the 4th. The other way to think about it is, what do I need to multiply x squared by to get 2x to the 4th? 2x squared. And then, just like with our normal numbers, we're going to take whatever's on top and we're going to multiply that to the stuff that's on the outside. And that's what we're going to write underneath. So 2x squared times x squared gives us 2x to the 4th. And then 2x squared times 2x gives us 4x cubed. And then 2x squared times negative 3, negative 6x squared. Now, what operation do we do as we're going down? Subtraction. So 2x to the 4th minus 2x to the 4th gives us what? 0. And that first one always has to add or subtract 0. Okay? Otherwise, it means we picked this top number incorrectly. Okay? We need those first two terms to go away. Well, it just so happens, what is 4x cubed minus 4x cubed?
0.
We also get 0. Well, that's nice. Then be careful on this last one, because what is negative 5x squared minus negative 6x squared?
Negative 1. Just 1.
Positive x squared. Okay. So now basically we need to start over the same process, but with our new numbers. So if I have 3 terms on the outside, I also need to have 3 terms on the inside. So that means that we need to bring down our 3x and our negative 2. And then, like I said, we're going to start the process over again. What do I need to multiply x squared by to get x squared? Just 1 this time. And again, we're multiplying. So since we're multiplying by 1, we just get the stuff that's on the outside. And again, we're going to subtract. So what do we get when we subtract? 0. X.
Negative plus 1.
Positive 1. So can I do it again? Why not? Because now it's a smaller degree than what we're trying to divide by. So notice that x plus 1 has a degree of 1. My stuff on the outside has a degree of 2. So there's not anything that we could multiply x squared by to get x. So what does that mean x plus 1 is?
Remainder.
It is our remainder. Okay, so then we said that we're going to write this out. Okay, so we're going to put our quotient first. So 2x squared plus 1. And then we want to add our remainder. So x plus 1. But we need to put it over our original divisor, which was x squared plus 2x minus 3.
I have Connor Carpenter for checkout, please.
Yes.
Thank you.
No, I gotta learn this first.
This one?
Yes.
Okay, so we said, what do I need to multiply x squared by to get 2x to the 4th?
So you need to multiply 2x, or you need to multiply x squared.
By
By
2x squared to get 2x to the 4th.
Okie dokie. I'm gonna take a picture of this.
Other questions on that? That is your answer. So 2x squared plus 1 plus x plus 1 divided by x squared plus 2x minus 3.
You do the, oh, so like the number on the outside, the divisor.
The divisor.
Only plug in the first number, so like with the highest.
Correct. You only have to worry about the x squared.
So like if there was like a 3x cubed in front of that, you could do that one.
Instead, yes. You only use that first one to decide what you need to multiply by. Alright, other questions? Otherwise, we're just going to do some practice.